Welcome to the Pepperl+Fuchs Level Product Basic presentation. My name is Chris Romano and I am the Product Manager for the Level Products here at Pepperl+Fuchs. This presentation will talk about what Pepperl+Fuchs has to offer in level monitoring and control products, with a wide range of different technologies to be used. The first section of this presentation, we will deal with point level control or limit detection. This is like a single point or multiple point control. And the offerings we have are the float switches, the Vibracon forks, the magnetic immersion probes, conductive and capacitive probes. The point control or limit value detection indicates whether the medium being monitored has been reached, risen or above or fallen below a certain level. Examples of these are for run-dry prevention, min-max control, or overspill conditions. Probably the most basic point level control product that we have is the float switches or the LFLs. You can get these in spherical or ball type solutions. You can get the material of the cable can be PVC, PUR, CSM, and up to 30 meter cables, depending on the medium you have. The material body can be polypropylene. We have different types of outputs. We have a NAMOR output for hooking up to a intrinsically safe barrier or for isolation, contact, or PNP 3-wire type outputs. These are all mercury free. There's a ball inside these switches that activate a micro switch. They can come with ATEX for the EXIA, which would be your NAMOR output to an intrinsically safe barrier. Very good for point level sensing for overflow conditions. The LFL1s give you the NAMOR output, LFL2s the contact output, and the LFL4s will give you the 3-wire PNP output. Here is an example of a float switch in a wastewater treatment area. And this happens to be a customer on the left has made their own little bracketing for the float switches so that they can be submerged inside the medium. And then on the right is our ball type float switch. The LFLs are only for liquids only. The next point level monitoring control products we have is the Vibracon. And these are basically a vibrating forks that will dampen when the medium reaches the fork lengths. The Vibracon works with a piezo element in the bottom where the forks extend out. And we actually exercise this crystal on there so that it vibrates. And it vibrates at a certain frequency. And when the medium reaches a certain level inside the forks, they dampen that frequency and we get a shift in the frequency which we detect and give it as an output. Now this shows you the switching points of the forks, whether it's mounted from the top, bottom, or on the side. The one thing to note about the Vibracons is that you will have two forks coming out, they vibrate. They could have a buildup on them. Now, these pictures here give an example of the buildup that's capable on these Vibracons and still be able to work. As you can see from the top, it's pretty symmetrical as far as the buildup, but even if the buildup is not symmetrical, it can still work properly. As well as buildup, you could have corrosion on the forks. So loss of metal, even though it's vibrating at a certain frequency, the loss of metal, we're still able to see that differential vibration and give an accurate output. And according to this, all of these types of corrosion on the probes, these probes will still work. The Vibracons, they're pretty hardy probes. They can be damaged. You can bend the forks. We don't suggest that, but they can be and they can still work. They're pretty resilient against pressure changes, suspended solids inside there. Viscosity changes, density changes, and like we saw, material buildup and corrosion on the probes themselves. Turbulence, it seems to be pretty good with all of these types of changes in your liquids. Now we have a family of different LVL Vibracons. The LVL-A is our less expensive units. Basically come with a DC output or an AC 2-wire type output. Very simple. You don't really get them in an extended fork, but they can be mounted from the sides or bottoms of the tanks and so on. The A7 is our standard. The A7H is a hygienic type probe with the tri-clamp fitting and the finish on it. The next versions are the LVL M1s and M2s. The M1s is a standard length, one length, and the M2 you can get with an extended length probe. And the LVL M1H and M2Hs, again, the H indicates the hygienic type, tri-clamp fittings and so on. And then the LVL-M2Cs, which is a coated probe for very corrosive areas where a Hastelloy or even stainless steel are corrosive to. I should also say that in the LVL M1s on up, you can get in different types of process fittings, flanges, DIN flanges, ANSI flanges, and again, the hygienic fittings and so on. Along with these probes, we have all the FMCSA, ATEX certifications, and the NACE certifications, and even the 3A certifications for the hygienic ones. Now, another Vibracon version we have is for bulk materials. That's the LVL-Bs, and that can be used in bulk. It's one of the first probes we've seen here that can be used in bulk materials. The LVL-Bs has a single fork coming out of it so that the powders or the bulk material can't hinge against the two forks, so it's a single fork. Very good for sand, cement, anything powdery, bulk materials. The next point level control we have is the magnetic immersion probes, which are the LMLs. You can get this in single or multi-point. Now this probe has a reed switch inside there. And for multi-points, we just put the reed switches at different heights that you want to detect, the medium with. And then the float will, it's a magnetic float, so as it moves up and down the rod, it activates the reed switches. Maximum length is about 2 meters, and that's really about for shipping purposes too. So about 2 meters is the max. We have 3 different versions of the LMLs. The LML-S, it's a basic version, not intrinsically safe or not hazardous location ability. Max length is 2 meters. You can have up to 3 contacts in this unit. The rods are stainless steel. You can get this in a ball or cylinder. And just like the float switches, you can get in ball and cylinder. The ball floats on the surface easier than the cylindrical type units. And then you can get them in different threads. Right now we show G1.5, G2 threads, but they also come in NPT threads as well. And then you can get this in a Form C contact output. The LML-EX is basically the same as the LML-S, except it has a certification on it for ATEX only, for EXIA. And then the LML-P, which is a PVD or polypropylene, depending on what you want, as a float unit. 3 contacts, max length is 1 meter though, and it is for non-hazardous locations. Another point level control that we offer is the conductive probe, the LKL and the HR probes. The principle behind the conductive probes is they are for point level control, and they measure the conductivity of the liquid. Like if you have measuring the conductivity between air, it's very high, as opposed to when the water reaches the 2 probes, it will activate the switch. These come in rod or cable versions. Obviously the cable versions for longer lengths. There's no moving parts in them because it's all conductive. And you can do 2-point control for min-max, and you can also add additional points for detection, up to about 5-point control in one housing. No calibration, and the minimum conductivity of liquid must be at least 10 microsiemens per centimeter. A typical application is an oil separator type system. Here we show a conductivity probe in a oil-water mixture. Now, obviously, the oil is going to be floating on the surface of the water. So as this rises, probe's not going to detect the oil because it has a very low conductivity. But as soon as it reaches the water level, it will detect it. So it detects when the water level gets to below the oil. The family of conductive probes, the first ones we have are the LKL-P1s and P2s. This is like a plastic housing. This is the most common, less expensive unit that we have. The LKL P1s, the P1s indicate the rod version, the P2 indicates the cable version. P1's maximum length is about 2 meters. The P2s, you can get up to about 30 meters, 20 meters. I think it's about 25 meters. And you can get up to 5-point control on this. So you can have 5 rods or 5 cables coming down. Obviously, if you're using 5-point control, the tank must be metal so that you can get your signal back from the conductivity of the liquid, because it basically has to have a path for the electric to go through. So for cement tanks, if you have 5 electrodes, you can only have 4-point control. If it's a metal tank and you can use that as your ground reference, then a 5 probe can have 5-point control. The HR 69012 is a single-point conductive probe used for deep wells. You can order this in a 5, 10, and 20 meter length cable. The HR6, the ones on the right, the 2 ones on the right, HR-6 and the HR-6 blank 1. The one is 5 points up to 5 electrodes on it, and then the other one is a single point. The HRs are an older product, legacy product, but you can get them in a stainless steel housing with a couple more options on them. The last of the point level controls we have to offer is the capacitive limit switch, the LCLs. This limit switch is basically for bulk solids. You can get a rod version or a cable version. The housing material comes with polyester or aluminum. They actually have an active buildup compensation in there so that if you have a little bit of dust or buildup on the probe itself, it can compensate against that so it doesn't trigger the switch when there's nothing there, but just the buildup. You can get them in a AC Form C contact output or DC PNP output. They have a certification from FMCSA as well as ATEX for dust ignition proof. Again, the applications for the capacitive limit switch is for bulk materials. And here we show some of the dielectric for some of these different bulk materials. And as we see here, anything under 1.6, including 1.6 for dielectric, doesn't make for a good, you really can't use the capacitive probes. But anything over 1.6, 1.7 and greater, you can use the capacitive sensors to sense the material. The continuous level measurement probes we offer will give you an analog output according to the where the height of the medium is in the tank. What we have to offer as far as continuous level is the hydrostatic pressure sensors, the level gauge probes, which is another type of pressure probe, ultrasonic sensors, and the guided wave radar systems and the radar microwave systems. Continuous level measurement means that we detect the current fill level. So wherever the level is, we can give a 0 to 100% wherever it is in the tank. Usually this is a 4 to 20 milliamp output, but we also have some Profi bus, field bus, and a lot of these units with the 4 to 20 milliamp are HART compatible. Examples of usages for evaluating where the levels are in the tank. Also loss control. They can tell when you're losing something for billing purposes and for precision process controls for medium intake and outtake. The magnetic immersion probe, the LMLC, is a continuous type. Unlike the LML, which is a limit, the LMC gives you the continuous type output. And there are little reed switches all the way along that rod version there. It gives you either a resistive output or a 4 to 20 milliamp output, and they can be used for a wide range of liquid applications. Like the LMLs, we have 3 different versions of the LMCs. The EX version, the maximum length is 3 meters. Now, like I said, there's reed switches all along that rod, and the resolution of this LMC-EX is about 5 millimeters. So every 5 millimeters, there is a reed switch with a resistive network on it. Can come stainless steel. You can get the floats ball or cylinder. We show the threads here, G1.5 or G2, but they also come with NPT, and you can get them in the flanges, ANSI or DIN style. The outputs are 4 to 20 milliamp or 3-wire potentiometer, and this particular one we have an ATEX EXIA certification. The LMCP is a plastic version. Again, the maximum length is 3 meters. However, the resolution on this is 10 millimeters. So every 10 millimeters, you'll get an update of where the level is. It's plastic. You can only get the cylinder. It's restricted on the number of types of threads you can get or the process connection you can get. We do have the G and the NPT threads on there. And you can get this in a 3-wire potentiometer output. And then we have the LMC-S. This is very similar to the LMC-EX, except it doesn't have the intrinsically safe certification. The LUC-M is an ultrasonic sensor. It will actually send out a sound wave from the probe, bounces off the medium, comes back to the probe head, and the amount of time it takes to send and receive will indicate where the level is in the tank. As you can see here, it sends out a signal, bounces off the medium, comes back. Now, with the ultrasonic, because of the speed of sound, there's a certain block and distance from the probe head down that cannot be used. However, that's very short compared to the length of the medium it can detect. Now, the ultrasonic, again, uses sound wave to send and receive its signal. Because it's very robust signal, air moisture pressure is irrelevant to the signal coming back as far as the speed. Temperature can cause fluctuations in the speed of sound. However, we do compensation inside there, so even temperature changes are compensated out to give you an accurate signal and accurate level. Now, when you're looking at the medium it's bouncing off, you have to consider the actually surface of the medium. Ideal conditions is completely smooth and a hard liquid surface. Even if you have light foam, large bubbles, it can still bounce off there, but there's a point where it will not give a good signal back. And as you can see here, if it's a thick, light foam, then it probably won't give a good signal back and you'll lose the signal in the top layer of that medium. But everything else, it gives you a pretty good signal back. This is an example of a sludge storage facility, a cement tank, and they have the probes stuck on the end of a bracketing that they made. And you can see the chart off to the right. That unusable range is basically your blocking distance where it can't be used. However, you can see the signal running through the air, bounces off the medium and is coming back. And you can see where it's detecting it around 2.4 meters and gives a pretty good signal back, a dB signal back for indication of where the medium is. Another type of continuous measurement probes we offer is the pressure sensors. We have them in a compact version, extended versions, cable versions, rod versions, and process connection versions as well. The pressure probes uses the fact that there's a piezo element on the face of the sensor, and as the force exerts on this, it produces a signal, and we convert that to a workable 4 to 20 milliamp and so on. And we can get these in, they can measure absolute pressures and gauge pressures as well. The ceramic sensor that's located at the face of the sensor actually measures as the liquid rises, it produces more force on the face, and the ceramic sensor gives an output according to the pressure. And again, we can get these with a gauge output or a absolute pressure cell. They can actually take up to about 100 times overload resistance than the pressure that they're measuring. The resistance to alternating loads, hydraulic hits on it, and so on. They have a long-term stability of about 0.1% per year. And with the different variations of probes we offer, they will be used for different industries, like the process industry, chemical power, utilities. The LHC-M51s are probably your best bet. You can get these like in the process connection here, where they can be connected to a pipe for measuring the pressure inside there, as well as on the bottom of a tank. The hygienic industry will use the PPC-M51s and the LHCRs-51s. Now, these will have a hygienic fitting on the process connection, such as like a tri-clamp fitting, but they also have a finish on it that's suited for the food industry and so on. The next is the environmental industry, being water and wastewater. We offer the LHCS51Gs and the LGC2 probes. This happens to be a cement factory plant where it's actually measuring the pressure in that control nozzle and sending back a 40 to 20 milliamp output. And you can see where it's located. It's located up there by the pipe in the doghouse there, and it's measuring the pressure pipe. The level gauge probe, LGC2, which is your environmental probe, is basically used for freshwater wells and lift stations. It can also be used for wastewater areas. The nice thing about this is you can get it in a 300-meter cable. So for very deep wells, it's very suited for that. And it can be fully submerged in the medium. It's fully sealed enclosure. And you can make them intrinsically safe. Range is up to about 300 psi. This shows you an application of the LGC, and you see it going down the probe. We actually offer process connections with a housing that can house the temperature transmitter. So this LGC probe can also give you temperature outputs. So with a temperature transducer, you can get a 4 to 20 milliamp output for the temperature inside there, as well as a 4 to 20 milliamp output on the level. Now, Pulscon's LTC5s are the guided wave radar systems, the LTC50, 51, and the 57. The Pulscon LTCs, they offer some unique features in there. They have a diagnostic status signals, where it can actually indicate when something's interfering with the signal and so on. It can come with Packware, Profibus, HART. They're user programmable through the Packware or through the display. They're gas phase compensation, so you don't have to worry about that. You can actually compensate that out. You can map out the distance, like if there's a ladder inside there or there's something interfering with the signal, you can actually map that out so it ignores it, but it will detect the liquid. They can linearize the tank dimension, so if it's a cylindrical tank on its side, you can make that a linear signal output according to the gallons or liters inside the tank. Now off to the right, we show some yes and no's on how to mount it. The correct one is near the tank wall, and what this does is the tank wall actually acts as a return signal for the guided wave radar system. And you never want to put it in the stream of the water because you can't really map that out. If it was a stationary ladder there all the time, yes, but not, sometimes the water's coming in or the liquid's coming in or not. But so the one on the left is probably your best solution for mounting. In our manuals, we give detailed information about how to mount these and how to map out all this information inside there. The LTC50 is the low-cost version. Comes in rod or rope version, 2 meters or 12 meter lengths for the rope version. You can get them in different process connections. There is a menu operation inside there. You can program it for just about anything. It has up to SIL 3 certifications, and they also can be certified for HAZLOC areas. The LTC51 is a little bit more, you get a little bit more options. You can get the rope up to 45 meters, and then you can get a coax up to 6 meters. The coax would be used for tanks that are cement and you don't have a good return back from your, you can't guide your radar signal back. So the coax would be your best bet. Process connections, you can get NPT, DIN, ANSI, G-threads, and so on. Unlike the LTC50, the LTC51's flanges are available. 200C max operating temperature option. and again, SIL 3 as well as the HAZLOC certifications. And then the LTC 57, mainly used for like bulk material, rods 2 meter length, the rope is 45 meter length, PA coated for the bulk materials, DIN, NPT, G threads, and so on. SIL 3 along with the HAZLOC certifications. Here's an application with one of our LTC 57s on a salt silo, about 20 meter high, and you can see it positioned there. Again, you can see the silos and the upper right hand corner, that's cable coming down detecting the salt. Now, because this is a cable and it's bulk material, many times this cable will come down, it'll be tied off on a weight, and the weight can be tied off to the bottom of the tank so that it doesn't move around or gets tangled up into the bulk material as it rises and falls. Another type of radar probe we offer is the freestanding LCR radar. Unlike the guided wave radar where you send the signal down the rod and it reflects off of the medium surface, the freestanding is almost like an ultrasonic, except it has a much higher frequency to send and receive off the medium. The LCR-10 is offered in a 4 to 20 milliamp output. You can commission it through the Bluetooth because these are wireless. It's only available with non-hazardous area applications, plus or minus 5 millimeter accuracy, minus 40 to plus 60 degrees C ambient and process temperature range. The LCR-20, we offer this with a 4 to 20 milliamp output with HART output. So you can commission it via the HART or PACware or through the wireless Bluetooth. You can get this up to a 20 meter sensing range. We do have gas hazardous approvals for the LCR-20s. The ambient temperatures are minus 40 to plus 80, so it's a little bit better than the LCR-10s. Because the freestanding radar is so similar to the ultrasonics, we have a comparison chart here when to use one or the other. For gas layers, because of the high frequency of the freestanding radar, it will penetrate that better than the ultrasonics, give you a much better signal back to the radar system. Crosswinds, you could lose in outside applications. The wind can you can actually lose your signal from the ultrasonic, whereas the high frequency will penetrate that. Temperature gradients, even though the ultrasonic has temperature compensation in there, that's changes in the temperature. Temperature gradients, we don't know what the temperature is far away from the probe, so these temperature gradients will affect the accuracy of the ultrasonic, but not the freestanding radar. Icing and heavy condensation, you're better off with the ultrasonic sensors. And these happen to be some applications that we have used the LCR probes in. And obviously, many of them you could use either the pressures or the LMCs or the ultrasonics in there as well. But the LCRs are non-contact with the medium and a little bit better for the signal coming back in these types of applications. This concludes the Pepperl+Fuchs level product basic presentation. My name is Chris Romano. I am the level control product manager for Pepperl+Fuchs. Thank you.